in my last video we have discussed 7 points. Next we will go for the 8th one, that is energy of the orbitals. Now here energy of the orbitals we are going to study for hydrogen separately and for other atoms separately. First we will study for the hydrogen. For which atom? Hydrogen atom. Now just remember, for only hydrogen atom the energy of orbitals directly proportional to the principal quantum number, that is small n, but not on the azimuthal quantum number L. What is meant by principal quantum number? What is meant by azimuthal quantum number? We will discuss in the next point. Right now, just think, energy of orbitals for hydrogen atom directly depends upon the principal quantum number. If the n value is more, then the energy of the orbital is also more. Right now, for that one, for basic, I am taking one of the rough paper here. Now, for example, how to identify the n value, how to identify the L value for the given subshell. First we will discuss. It is very important. Write the n value and L value in this way, right? He may ask, right, in the theory examination. Now just to think, n value how it is identified, L value how it is identified for the given subshell. For example, if 4s is there, the question is what is the n value, what is the L value, how to identify. For this one I will give hint. First you should have to remember this one. Here L value and here subshell. Here I am writing L value, here I am writing subshell. 0 1 2 3, 0 1 2 3. Right now, when L value is 0, S subshell. L value is 1, P subshell. L value is 2, D subshell. L value is 3, F subshell. That is 0. L value is 0, S subshell. 1 for P subshell. 2 for D subshell. 3 for F subshell. S means L value is 0, P means L value is 1, D means L value is 2, F means L value is 3. Just remember, and always subshells are written in the form of NL. Always subshells are written in the form of NL. First number indicates n value, therefore n is equal to how much? 4. And this second symbol, that is S, indicates L value. S means what is the L value? 0. That is L is equal to 0. Similarly, write on another 5D. What is the n value? What is the L value? This is the question. Now just to check, I told already the first digits, the first number indicates n value, therefore n is equal to how much? 5. And D is there. D give the L value. D means what is the L value? 2. Here S means 0, P means 1, D means how much? It is 2. Therefore L is equal to how much? 2. Now third one is 4F. Right here, what is the n value? What is the L value? Write down directly. Write down. What is the n value? 4. F means what is the L value? 3. In this way you have to identify n value and F value, L value for the given subshell. Now here, depending on the n value, it is not depends upon the L value, right? For hydrogen, energy of orbital directly depends upon the principal quantum number, not on the azimuthal quantum number, that is small l. Now I will write the order first. Order of increasing energy level of orbitals in the hydrogen atom. Now what is the order is? 1s is having lesser energy than 2s, and 2s and having same energy that of 2p, right? These 2s 2p are having lesser energy than 3s 3p 3d, and this 3s 3p 3d all are having same energy, and it is lesser than 4s equal to 4p equal to 4d equal to 4f, etc. In this way we have to continue. Now my doubt is, here 1s, what is the n value? 1. Therefore it is having lesser energy. Here 2s and 2p, what is the n value? Here also 2s. In the 2s also n value is 2. In the 2p also n value is 2. Therefore both 2s and 2p are having same energies. Here 3s n value is 3. In the 3p n value is 3. In the 3d n value is 3. Therefore these three are having same n value. Therefore these three orbitals are having same energy, etc. Now we will discuss for the other atoms. For other atoms, now we will see the other atoms. For other atoms, here energy of orbitals depends upon both n value and el value. N means principal quantum number, L means azimuthal quantum number. Just remember. Now I will give the direct order. Now what is the order is, already we have studied Auger principle. There we have studied that increasing order of energy of different orbitals or subshells, right? That is only I am writing here. The order is 1s having lesser energy than 2s, 2s having lesser energy than 2p, 2p is having lesser energy than 3s, 3s having lesser energy than 3p, 3p having lesser energy than 4s, 4s having lesser energy than 3d, 3d having lesser energy than 4p. Next it is having lesser energy than 5f, 5f having lesser energy than 4d, lesser energy than 5p, next to 6p, etc. This is the increasing order of energy of orbitals, different orbitals or subshells in the other atoms, not for the hydrogen. Now just think here 1s, 2s, 2p, 3s, 3p. After that we think that 3d should be there, 3d should be there, but actually here it is 4s. Actually it is 4s. Why this 4s is having lesser energy than the 3d? It is the question again. Why this 4s is having lesser energy than the 3d? Next topic we are going to discuss this only, right? The topic name is n plus l rule. Next we will go for the n plus l rule. Now ninth point. For this one I will use another paper. Now ninth one. N plus L rule for identifying the energy of the orbitals. Now I will tell the rules directly. Already we have discussed in the theory classes. Now first rule is, if the subshell is having higher n plus L value, more will be the energy. If n plus L value is more, then the energy will be more. N, you should have to identify the n value, you should have to identify the L value, then add both, that is n plus L. Now the subshell which is having higher n plus L value, more will be the energy. Lesser n plus L value, less will be the energy. Second is, next some students will have the doubt, if the n plus L values are same, then what is the situation? If two or more subshells are having same n plus L value, then if it is same, then only, right? If the subshells are having same n plus L value, then only higher the n value, more will be the energy. Higher the n value, more will be the energy. We will discuss one example. First we will take 3d and 4s. Which one is having more energy? Here in 3d, what is the n value? 3. What is the L value? 2. 0s, 1p, 2d, right? Therefore n plus L value is how much? 3 plus 2 is 5, right? Here 4s, what is the n value? 4. What is the L value? S means 0. N plus L value, that is 4 plus 0 is equal to how much? 4. Therefore 4s is having lesser n plus value than the 3d, right? 3d having how much n plus L value? 5. 3d orbital or subshell having how much n plus L value? 5. 4s is having how much n plus L value? 4. Therefore 4s is having lower n plus L value compared to the 3d. Therefore 4s has lesser energy than the 3d. Clear? Now only I asked the doubt, na? Right? That is the answer because of n plus L value rule, right? Next, this is first rule over. For second rule, I will take another example. Just think here for another example. 5s 4p. Here n value is 5. L value is S means 0. Right here n value is how much? 4. First number 4. L value is 0 is S, 1 is P. 1. Here n plus L value. 5 plus 0 is 5. Here n plus L value. 4 plus 1 is 5. Both are having same n plus value. Right here 5s and 4p are having same n plus L value. Then which one is having higher energy, which one is having lower energy? I told if the orbitals are having or the subshells are having same n plus L value, then go for n, higher the n value, more will be the energy, in the first 5s. What is the n value? 5. In case of 5s, what is the n value? 5. In case of 4p, what is the n value? 4. Therefore 5s is having more n value, higher n value. Therefore 5s is having larger energy, more energy than the 4p, because both are having same n plus value, but here n value is more, therefore it is having more energy. This is called as what? N plus L rule. Now this is also over. Next we will write next point, that is 10th one. Nodes or nodal surfaces means where the probability of finding electron is 0 na, that surface is called as what? Nodes or nodal surfaces. Now we will see. Right now directly I will give the formula, no need to think about this one. First, number of radial nodes is equal to, formula is n minus L minus 1. Next, second one, number of angular nodes is equal to L. Right. Third one, total number of nodes equal to radial nodes plus angular nodes. If you add both radial nodes and angular nodes, you will get the total number of nodes. Radial nodes is n minus L minus 1 plus angular nodes is L minus L plus L cancel. Therefore it is n minus 1. Total number of nodes, what is the formula? N minus 1. Right. Radial nodes n minus L minus 1. Angular nodes L. Total number of nodes n minus 1. It is also very important for the objective questions. Next we will go for the last concept, that is quantum numbers, and it is very, very important. Next, 11th 11th one is quantum numbers. Now quantum numbers. Now already you know quantum numbers helps to identify what? Main shell in which the electron belongs, subshell in which the electron belongs, and also the orientation and also the spin orientation, and also number of orbitals. It will give information about number of orbitals. Right. Now quantum numbers gives the information about main shell, subshell, number of orbitals, and also the spin of electron. Now totally there are 4 quantum numbers are there. Already we have discussed it very deeply in the theory classes. Right. 4 quantum numbers are there. What are those? Principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. 4. I am writing those 4 only. Now principal quantum number. Here the symbol is small n. First we will discuss one by one. What is the use of principal quantum number? Now principal quantum numbers always helps to identify the main shell in which electron belongs. Main shell, right, in the orbit. First shell, second shell. Here I will draw the diagram also for more clarity. If it is nucleus, first shell, second main shell, third main shell. Here n is equal to 1, n is equal to 2, n is equal to 3, etc. n is equal to 4, 5, 6, etc. That is the main shell. This is the first main shell. This one is second main shell. This one is third main shell, etc. Main shell in which the electron belongs, and also it will give the information, that is size. Size is directly proportional to n value. N value 1, this much of size. N value 2, more size. N value 3, more size, etc. That is n value directly proportional to size. N value, that is principal quantum number, directly proportional to the energy. Energy. Now, what are the n values? N is equal to, it may be 1, 2, 3, 4, 5, etc. but not 0. Now, in 10th, we have studied that n is equal to 1 means K shell, L, M shell, N shell, etc. Now, maximum number of subshell in main shell. Again, we already studied the points, right? Now, these you should have to remember. Maximum number of subshells in main shell is equal to how much? N. And also maximum number of orbitals. Maximum number of orbitals in main shell is equal to n square, and also maximum number of electrons in the given main shell is equal to 2n square. This much of information you should have to remember about the principal quantum number. Next, we will go for the second one, that is azimuthal quantum number. Azimuthal quantum number. Now, just remember n is equal to 1, 2, 3, 4, etc. but not 0. Next, azimuthal quantum number. Azimuthal quantum number. The symbol is small l. Azimuthal quantum number symbol is small l. Now we will see. Here it is. It gives information about what? Shape, right? And also subshell. Right? These two informations can be obtained by using the azimuthal quantum number. Now, how the shape is identified, how the subshell is identified, for this one I will give the one table, one best table, right? We will draw that one first. Here I will take L value. Here I will take subshell. Here I will write shape, right? If the L value is 0, that subshell is S subshell, and the shape is spherical. Already we have studied, right? If L value is 1, then it is P subshell, and the shape is dumbbell. Next, if L value is 2, then it is D subshell, and the shape is double dumbbell. If it is 3, then it is F subshell, and it is complex or triple dumbbell. Just remember, when L is equal to 0, S subshell and its shape is spherical. When L is equal to 1, P subshell and shape is dumbbell. When L is equal to 2, D subshell, right, it is shape is double dumbbell. 3 means F subshell and it is, what is the shape? Complex. What is the formula to calculate the L values? Is formula, very important. Very important formula. This table is also very important, and this formula is also very important. For a given n value, right, L is equal to 0 to n minus 1. For example, n is equal to 2. What are the L values? Right, 0 to 2 minus 1, 0 to 1. Therefore, it is 0, 1. Right, that is, let us solve two examples. When n is equal to 2, L is equal to 0 to n minus 1, that is n is 2, 2 minus 1, that is 0 to 1. 0 to 1 means 0, 1. Two values, that is S subshell is possible and P subshell is possible. When n is equal to 3, L is equal to what? 0 to n minus 1 means 3 minus 1. That is 0 to 2. That is 0 comma 1 comma 2. S subshell is possible, P subshell is possible, D subshell is possible, etc. In this way we have to calculate the L value. Next we will go for the magnetic quantum number. Magnetic quantum number. Third one. The symbol is small ml. Small ml. Now, here it will give information about number of orbitals, and also the orientation of orbitals. Now, we will see first one by one, right? The formula for this one is ml is equal to 2l plus 1. This is the first formula. It gives possibilities, not the particular value, possibilities, right? Now, for example, if example I am taking, if L is equal to 0, ml is equal to how much? 2 into 0. L value is 0. 2 into 0 plus 1, that is equal to 1. Means only one orbital is there. It will give number of possibilities or number of orbitals, not that orbital, right? Now, if for example, now another example, if L is equal to 2, I am not taking serial wise, L is equal to 2, ml is equal to how much? 2 into 2, 4. 4 plus 1 means 5. 2 into 2 plus 1 is equal to how much? 5. Means 5 orbitals are possible. 1, 2, 3, 4, 5. Right? L is equal to 0 means which subshell it is? S subshell. S subshell means how many orbitals? 1. Correct? L is equal to 0 means which subshell? Yes. Yes, having how many orbitals? 1. Next, L is equal to 2. L is equal to 2. 2 means it is D subshell. Right? I'm not taking 1. Right? Here 2. 2 means D subshell. D subshell having how many orbitals? 5. What are those? Here it is 0 plus 1 plus 2 minus 1 minus 2. We have discussed dxy, dyz, dzx, dx square minus y square, dz square, etc. If L is equal to 1, which subshell it is? P subshell. Right? Put ml is equal to 2 into 1 plus 1. Right? In place of L I am writing 1. That is 3. 3 orbitals are possible. For P subshell, how many orbitals are possible? 3. What are those? Px, py, pz, etc. Right? If L is equal to 4, right, you only have to calculate how much it is. 2 2s are 4. 4, right? 4. Here 2 into L value is 4 plus 1. 8 plus L value, sorry, 3. Let us take 3 for F subshell. For F subshell, L is equal to 3. L is equal to 3. ml is equal to how much? 2 into 3 plus 1. That is 6 plus 1. That is 7. 7 orbitals are possible. 1, 2, 3, 4, 5, 6, 7. Right? F. Now, here it is. L is 3. Right? Minus 3 to plus 3. You have to number minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, etc. etc. In this way, it will give the information about the number of orbitals. Just remember very important thing. S means how many orbitals are there? 1. Here. S means how many orbitals? 1. P means how many orbitals are there? 3. D means how many orbitals are there? D. Here it is 5. 1, 2, 3, 4, 5. F means how many orbitals are there? 7. Here it is 1, 2, 3, 4, 6, 7. In this way, it will give information about the number of orbitals. Next, we will go for the spin quantum number. Last one. After that, we will solve 2 to 3 examples. Last, spin quantum number. Here 2 possible values are there. Plus of, minus of. Plus of means upward direction, minus of means downward direction. Plus of clockwise, minus of anti-clockwise. Just remember this one. Enough. only two possible values, either maybe plus of or minus of for the spin quantum number, and its symbol is m small s. M small s. Now we will take few examples. Quantum numbers very important for the competitive examination point, or it is very important for the objective type of questions. Many questions arrived on the quantum numbers. Now we will discuss a few, right? How to solve that we will discuss. For example, I will take few examples, right? First one is, no, I will take particular examples. First one, now first question is, which set of quantum numbers is not possible? Which set of quantum number is not possible? He is asking question, right? He is giving options. Four options are there. Option A, B, C, D. Now here n is equal to 3, L is equal to 2, M is equal to 0, S is equal to plus of. Which is not possible he is asking. Which is possible he is not asking. Which is not possible he is asking. Next to second, n is equal to 2, L is equal to 2, M is equal to 1. Let us take S is equal to plus half. Next to third, n is equal to 3, L is equal to 2. Next to M is equal to minus 2 and S is equal to plus half. Next last one, N is equal to 2, L is equal to 1, M is equal to 1, S is equal to minus half. Which is not possible he is asking. Which is not possible he is asking. Now just to think, N value may be 3, correct. N value may be 3, correct? Correct only. L value is 0 to N minus 1, means it should be less than 1. L value should be 0 to n minus 1, means 0 to 3 minus 1, 0 to 2. 0 is possible, 1 is possible, 2 is also possible. And m is equal to 0. ml is equal to 0. If you put 2l plus 1, ml is equal to, what is the formula? 2l plus 1. Here L value formula is 0 to n minus 1, right? And ml value formula is 2l plus 1, right? If you put 2 here, 2 to the 4, 4 plus 1, 5. 5 orbitals are possible. What are the possibilities? Minus 2, minus 1, 0, plus 1, plus 2. Therefore 0 is possible. That is in between. This m value should be in between minus L to plus L. Then it is possible. Then it is correct. Just remember, hint it is minus L to plus L. 0 plus half is possible. For second option, just check. N is equal to 2. Okay, it may be second shell. L is equal to 2, possible or not possible? Just to think. What is the L value? L value is from 0 to n minus 1. Here, just here, 0 to n minus 1. That is 0 to 2 minus 1. 0 to n value is 2 na here. Second option, 2 minus 1. That is 0 to 1. 0 to 1 means 0 comma 1. Right? 0 is possible, 1 is possible, but 2 is not possible. Therefore, the correct option is B. Next here, 3 is possible, 2 is possible, minus 2 is possible, all are possible if you check, right? In this way, you have to solve, right? Next, we will go for the another example. Last. Now, next question we will take. Simple one. For principal quantum number n, for principal quantum number n is equal to 4, the total number of orbitals having L is equal to 3, is, options are there. Four options. Option A is 3, option B is 7, option C is 5, option D is 9. Now we will see the solution. We will try to solve this one. Now just to check what is given, the principal quantum number is n is equal to how much? 4. N is equal to how much? 4. Now here L is equal to how much? 3. L is equal to 3. Now you should have to calculate the number of orbitals. What he is asking, total number of orbitals for having L is equal to 3. N is equal to 4 means L is equal to 3 is possible. Wait a minute. Now, what is the question is, for principal quantum number n is equal to 4, the total number of orbitals having L is equal to 3 is, n is equal to 4 means L is equal to 3 is possible. It is correct only. It is correct only. Oh, now, number of orbitals is equal to, right? Which quantum number will give the information about number of orbitals? Magnetic quantum number. Ml is equal to 2L plus 1, that is 2 into L value is 3 plus 1, that is 2 3 is a 6, 6 plus 1, that is how much? 7. Therefore option B is correct. L is equal to 3 means, you should have to remember, L is equal to 3 means how many orbitals? 2L plus 1. Number of orbitals is equal to, what is the formula? 2L plus 1, that is 3 into 2, 6. 6 plus 1 is 7. 7 orbitals are possible, right? Now, next another question we will take. Our own question we will take here. Write n value, n comma L, ml and ms value for let us take 3s orbital or subshell. Now here 3s means, what is the n value? 3. What is the L value? Answer I am taking here. 3s means, what is the n value? 3. What is the L value? 0. What is the ml value? Ml value 0, that is 2L plus 1. 0 means 1 only one possibility, that should be 0, right? That only one orbital, that should be 0 orbital, 0th orbital, right? And ms, only one electron means it will be either maybe plus of or minus of. I'm taking plus of, or plus or minus half, anyone, right? In this way you have to solve the bits on the quantum numbers. Next we will go for the last concept, that is filling of orbitals, filling of electrons in the orbitals. Now 11 over last 12th point, filling of orbitals. Now for this one I am taking another paper. Here I will take another this paper. I will use this one. Now 12th, filling of electrons in the orbitals. Filling of electrons in the orbitals. 3 rules are there. It is very, very important for theory also, right? What are the 3 rules? For filling of the electrons in the orbitals, we should have to follow the 3 rules. What are those? First one is Aufbau principle. Second one is Pauli's exclusion principle. Exclusion principle. And the last one is Hund's rule. Hund's rule. Now, Aufbau principle, what it says? What Aufbau principle says? In the ground state, the orbitals are filled from lower energy orbitals to higher energy orbitals. Means first lower energy orbitals are filled, next higher energy orbitals are filled. That is, we should have to follow the increasing order of energy. What is the statement for this one? Statement is very important for the theory. Right? What is the statement? In the ground state of an atom, the orbitals are filled in increasing order of their energies. Right? That is the rule. That is only I wrote lower energy to higher energy. Means first lower energy orbitals are filled, next higher energy orbitals, or increasing order of the energy you have to follow. Next, second, Pauli's exclusion principle, what it says? Simply, in only one orbital, maximum 2 number of electrons added with opposite spin. If you add with the same spin, that will be wrong. That will be wrong. It should be opposite spin. It should be opposite spin, right? This is one statement. In the same orbitals, only 2 electrons are added with the opposite spin. This is the first statement. Second statement is, in the same atom, no 2 electrons can have same set of 4 quantum numbers. Means in the same atom, no 2 electrons, it is not possible. No 2 electrons can have the same set of 4 quantum numbers. That is also called Pauli's exclusion principle. Last one is Hund's rule. Hund's rule what says? For example, P means how many orbitals? 3. P means how many orbitals? 3. Means all these 3 are having same energy na? Same energy. All these 3 orbitals are having same energy. If same energy orbitals are available, if the orbitals are having same energy, then first you should have to add one electron to the each orbital. One electron to the each orbital. After adding one electron to the each orbital with same spin, next go for the pairing with opposite spin. In this way, first singly occupied, next pairing. First singly occupied, next pairing. For example, another example. 3 orbitals. All these 3 orbitals are having again same energy. If you want to add 2 electrons, if you add 2 electrons in the same orbital, that is wrong. That is wrong, because Hund's rule says that first all the orbitals which are having same energy singly occupied. First give one electron for all the orbitals which are having same energy. Same energy ittu andre ಏನು ಮಾಡಬೇಕಂತಂದ್ರೆ ಎಲ್ಲ ಆರ್ಬಿಟಲ್ ದಾಗ ನಾವು one electron ಹಾಕಬೇಕು, ಆಮೇಲೆ ಪೇರಿಂಗ್ ಮಾಡಬೇಕು. ಇದು ರೂಲಿಗೆ ಏನಂತಾರೆ? Hund's rule, right? Means first we should have to add one electron for the each orbital, because all these 3 orbitals are having same energy. One electron. It is correct. If 3 electrons, you should have to add this electron here. Next 4 electron means then go for pairing. This rule is called Hund's rule. What is the statement? Among the orbitals of same energy, electron do not start pairing until all the orbitals are singly occupied with parallel spin. This rule is called as what? Hund's rule. Now, this completes your complete synopsis on the next. One more last point. Now, one more extra point here I am telling. Stark effect, and another one is Zeeman effect. Stark effect means splitting of spectral lines. When you apply the electric field, the spectral lines goes on splitting, right? That effect is called Stark effect. That is only I am writing. Splitting of spectral lines in presence of electric field. Just remember, Stark effect means electric field is called as what? Stark effect. Means when you apply the electric field, the splitting of the spectral lines takes place now. That effect is called as what? Stark effect. Zeeman effect means man, M-A-N is there. That is magnetic field. Same, splitting of spectral lines in presence of magnetic field is called Zeeman effect. Is called which effect? Zeeman effect. Spectral light splitting in electric field, Stark effect. In magnetic field, Zeeman effect. It is also very, very important for theory as well as also NEET. He will give that what is Zeeman effect? 4 options. Splitting of spectral lines in presence of electric field, option A. Splitting of spectral lines in presence of magnetic field, option C. Next, option B, sorry. Next, splitting of spectral lines in both electric field and magnetic field, option C. Option D is none of the above. Right, your answer should be option B. That is, splitting of spectral lines in presence of magnetic field is Zeeman effect. In this way, you have to do. Now, we will stop here only. Thank you.